In this video, we will add some randomness to our obstacles, to our enemies, so they are moving unpredictably from line to line, also up and down, so vertically and horizontally. Let's begin. Let's talk about the changing of the lines. Let's imagine this is our enemy, our player, and what we want to do is randomly choose the line, either right line or middle line or the left line, and also on the up here on the Y direction, so we can go either with the enemy obstacle like this way here to the right, or all the way to the left side, or maybe we can go from top here back to the right one and down. So there are these combinations of the bottom lines and also these top lines. Okay, so same principle as we are spawning the enemies. We are spawning the enemies in these positions down here in the middle line, right or left, and also on the upper position in the middle line or right or left. Okay, I will return my player where it belongs, here in the middle with its positions minus 0.5, 0.5, and 0, and we'll be adjusting the script for our obstacle. Okay, let's get to our code, and we'll go to obstacle CS, and we'll create here a new serialized field, and this will be the frequency in which the enemy should change the line. So it's right here, private float m underscore and line change interval, line change interval, and let's say every 2 seconds, so 2.0f. Now we'll keep here a track of the timer, so private flow m underscore line change timer. Okay, it will be 0. You don't need to really write it explicitly here, but it's because it is 0, but you don't write anything. And if you want, you can keep it. Okay, so this is line change interval in our update now. Okay, so we'll write here if statement, and we'll be checking if the time, so if the current time is larger than our line change timer, then we can change the line. Okay, so we'll be changing the line, and also we'll be resetting the timer. So timer will be resetted to value of current time plus line change interval. So make sure you don't making any mistakes on the last tag I made. So this will be interval. So you are assigning the timer time plus change interval. We can also randomize it. So we can write here some randomized value, var random value. We can choose here random range, and random value can be, let's say, from 0 to 2.0. Okay, so every time we'll be spawning, and the next spawn will be chosen randomly from the value from 0 to 2. And we'll add to this time plus change interval plus this random value. So it will be changing in the random intervals a little bit. Of course, this interval you can change. The random value, maybe you can make it smaller if you want, or bigger, or larger, up to you. And also change interval here, you can change to the value you want in your game. Because lower value that you will have here, more often the lines will be changed. Okay, so when we have this, we can now create here a new method, can be private one, private void, and we will call it go to new line. Go to new line, or select new line. Select new line. Okay, and here we'll be writing select new line. By the way, the selection of the line we can copy from our game manager. We can make it reusable, or we can just simply copy it. Okay, copy it, get your obstacle, paste it here, select new line. The Z position here will be initialized to the 0. Okay, because we really care about X and Y position here. And it's complaining that we are returning here value, but we have void here. So right here, actually I can stay void. We don't need to return here anything. But rather we'll create here a new private variable, private vector3, and this will be the new position in which we want to get. So it's right here m underscore target position, and we'll get this target position. We'll get back to our select new line method, and we'll assign it this here. So this new vector3, we are only caring about the X and Y position in which we want to get, and this will be our new target position. Down here, I will separate this movement speed and delta time into the separate variable, because we'll be using it also in other code. So let's write here var speed equal this, and the speed we can use now down here. We can remove this 2 and replace it just by the speed. Okay. Now, when we will move forward on the z-axis as we are doing here, we will get our position, current position. So let's get here vector 3 and or just var and var your current position. And our current position will be new vector 3. And this will be our target position. So m underscore target position x. Okay, and if I think about this, doesn't make much sense to call it current position, but rather call it target position. Target position. And here we don't need to actually move at all. Let's comment it out at this position movement, but rather here construct this new vector target position where we want to move to. So will be target position x, m underscore target position y. We can actually make it like this so it's easier to see. And the z position will be the increment of the movement. So this will be transform position z plus speed. Okay, I think we can leave it this way. This will be better, I think. Okay, and then to move, actually, we can move this way as we have done here, or we can do it differently. I'm just thinking now if we are handling it correctly. I'm overcomplicating it. So this can stay. The target positions can stay, but we don't need to add here speed. It's just this will be our target position. We've calculated here, and we will move here with this. So let's uncomment this. So we'll move first forward. Then we will calculate the target position together with our forward position. And then we will use here a function called move towards. Okay, so now we'll try to transform position, and the new position will be vector 3 and to move towards. Move towards is very useful, so we will not go outside of the boundaries of our line, because here we can specify the current position in which we are and the target position where we want to go, and we will not go outside of the boundaries of this. So we'll get here target position. We specified up here and speed. Okay, this is better. Okay, with this, it should work. So let's save this, and let's see if we'll be changing the obstacle, will be changing line. It should change the lines every 2 seconds, right? Because the prefab, when you go to prefabs, obstacle enemy, when you will click on the obstacle enemy, in your obstacle here, you should have a line change interval. It should change every 2 seconds, plus this random value. So it can be 2.5, it can be 2.3, or 3, or 3.5. So depending what will be this random value here generated. But yeah, let's see. Let's play the game. And it should be moving forward. We'll just go to the scene view. And it's also changing. And it's changing. Let me see the game. It's changing super quickly, very rapidly from line to line. The forward is okay, as we had it before. That's fine. But yeah, it looks funny. But we should decrease it. So what we can do here we are handling our movement from the random movement. So the speed here we can decrease, let's say, divided by 5. So 5 times slower. And this speed you can adjust. Okay? So let's play the game. And let's see it now. Let's play this. Yeah, that's better. That's better. Okay. So, and yeah, you can increase it if you want still, or maybe decrease it even more, or maybe progressively. As your game will go on, maybe increase the speed, or I will leave up to you. But now it's much harder to avoid. We need to more jump, we need to move more. And yeah. Okay, so that's the new thing in our game. And that's end of this video. See you around.